Okay, then. So there are two goals for today. One is for us to work through the unit review for Unit 4. And I've got to make sure, I'm trying to think through, we'll probably have time to do both reviews. Let's see. Usually how I like to do this is we work through example problems and then you do your own problems and we check your answers. Like that's the best way to study math. Just watching me do the problem isn't particularly helpful since we've already done that, right, in the videos prior. So there's that. And then the other thing is we want to write up a review sheet for the Unit 4. And then I should just take this moment to remind you of what the review sheets we have. And then we'll also talk about the final exam. So first, let me show you where to get the other review sheets. Under the Zoom links for recorded sessions, since I finally started labeling them, there are reviews for each of the units, Unit 1, 2, 3, and then we're creating Unit 4's review today. So for example, if we go to this Unit 1 review A work through, this is where we did that first review in class. Here's how I'm showing how to do the Unit 1 project. Hooray, remember that 50,000 years ago? And I think somewhere within this video is me writing up an overview of reference sheet material. Now, of course, my computer is very slow because I'm compiling my previous class's video, so life is fun. So where am I? Let's just see if I can find. Anyways, somewhere in here, I'm writing it up. Maybe we don't need to waste time trying to find it. Jesus, this is slow. This looks like it, doesn't it? Maybe those are some example problems. Any rate, they're in here somewhere. I can try to look for them later so we don't take this time to do that. I know Unit 2 review, we did it right away because there was so much in Unit 2. Oh, good Lord. It's kind of embarrassing that I looked like that. Yeah, so right at the beginning, I wrote up the suggested reference sheet. Apparently. Did I really? I must have had to go take care of something in the home. Whatever. I don't know why I'm spending time on this. Okay, so let's do that now for Unit 4, and then we'll use that as our review, and then we'll talk about the final exam and how you get to use all those review sheets, and I'll show you where the final exam will be located, and that will be that. All right, so for Unit 4, we started with a discussion of probability in 4.1. So you need the definition of probability, like what is that? You need to know how to calculate it. So you know how to do calculations. And there were essentially two ways to calculate it. And it depended on whether you had a classical probability, is that what we call it, or an empirical probability. And classical was just, well, empirical was observations and classical was just the theory. So it was the number of outcomes in the sample space divided into the number of outcomes of the event. That was the probability of any given event. Whereas with empirical, it was the frequency of the given event divided by the total. So one used data, one used that theory. You need to know kind of the values of a probability. So the idea that it's any number between 0 and 1, inclusive of 0 and 1, that it can be a fraction, a decimal, or a percent. And you also need to understand what the word not means. In other words, the complement. And let's see, what else was in there? That's essentially it from 4.1. Y'all remembering that? Any questions on those? All right. Wait, did I cut someone off? No. Okay, so then 4.4, we learned a bunch of stuff, like just tons of language. And we started with, this was the beginning of statistics, our study of statistics. And you need to understand what's a sample versus a population. How are those two connected? You need to be able to identify a sample and a population from a study. You'll see some questions like that in the review sheet. There was also one on the 4.4 worksheet. You need to know the sampling methods, what they all are, and how to identify which method has been used. I guess I could list them here. If you go back to the 4.4 notes, I wrote up a listing of these that are also defined in your textbook. What I wrote is a little bit different than what's in the textbook. Mine is obviously better because I wrote it. That's of course my bias and what I think, but if you like what the author, how the author defined them, feel free to use his definitions. So there was random, systematic, cluster, and stratified. Those were the 4 methods. We then talked about qualitative versus quantitative data. No, we did not use that language. Let me try again. We didn't use the word qualitative. We used categorical. The author used categorical. I added in qualitative because that's what we use in our stats class. The same thing, categorical and qualitative, but just so we're clear. So understanding those two differences, then you need to be able to make frequency distributions, either grouped frequency distributions or categorical frequency distributions. You need to understand them. And from that, we also built a histogram, and we did stem and leaf plots. You'd be able to read those and kind of understand what's going on with that mess. And that was the bits and pieces from 4.4. 4.5, we learned the measures of average or center. Think about what you're doing in your project. I think we also use the word central tendency here. There are 4 of them. You need to be able to find them using Desmos on the exam. Mean, median, mode, and mid-range. And you need to be able to tell me which is the best measure. And you need to know when to tell which. You also need to understand what is an outlier and how does that relate to your mean and median. That was it for 4.5. 4.6 is measures of spread or variation. We learned about 3. There was range, there was standard deviation, and there was the coefficient. Don't confuse this with your unit 2 stuff, coefficient of variation. That is not how you spell variation. It's funny, I spelled it correctly above. Variation. I should remind you that there are symbols for these, sample population, sample population symbols. There are not for these other ones. Again, you need to be able to find these in Desmos or a calculator that you'll be allowed while you're taking the exam. And you need to be able to tell the story based on these measures. What do these things tell you about the data set? For 7, we looked at the normal distribution and all that is. We used the empirical rule to calculate probabilities, area under the curve, approximate amounts of data values that fall within given ranges. So expect to draw a normal curve and put in the mean and standard deviation in there and then do some calculations with it. We also calculated z-scores. So you need to know how to calculate that. I'll just remind you of the formula. This is a little different than what's in the book because the book uses the symbols. They use X, they use X bar or mu, and then they use S or sigma for the respective things, whether it's a population that you're working with or a sample. And then you need to interpret this, just like you're doing in the project with the milk data. Interpret, and remember, all it is a unit of measurement where the units are standards of deviation. So when you calculate a z-score, it really is a unitless measure. It's just the distance a particular data value is away from the mean measured in standard deviations. The last section was 4.9. Let's see what happens. And that section is misuses of data. So the main thing I focused on from here, we spent maybe 20 minutes talking about it, is misrepresentations in graphs. So for example, on the final exam, I found a graph. I tossed it on there. It's got some misleading information, like it's a poorly drawn graph. It was actually drawn that way on purpose to mislead the public, most likely for political reasons. And your job will be to look carefully at the graph, make sure you understand what it's saying. Just like you're doing in the project, you're picking one of those 5 graphs on that PDF, and you're just first reading it and saying, here's the information contained in this graph. And then you're saying, here's how it's misleading based on how you know graphs should be put together. And then you're offering a suggestion of how it could be less confusing, or how it could be clearer what the information contained. So this is what I suggest should be on your reference sheet. I'm not saying these particular words, like for example, the empirical rule, you should draw that graph with its stuff, right? That's what you need on your reference sheet. So go look that up, put in the percentages in between, figure out how you make sure you know how these numbers are calculated and written. That's what I'm looking for. Same thing here, put in the equation for this. I might as well do it now. It's standard deviation divided by the mean. Okay, any questions on this? All right. Was that too fast? Does anyone need to see it longer? Okay, good deal. So let's take a look at review A. This is 91. Does anyone know the answer to number one? In any experiment, the set of all possible outcomes is called the. I should have added this to the reference sheet. That's the sample space. I mentioned it, but I didn't state it. So let's add that back to our reference sheet for 4.1. You need that to calculate probabilities. That's what this S stands for, sample space. And what's most important is that you can count how many outcomes are in that sample space. So creating the sample space, stating it is important, but not as important as calculating the numbers. Okay, when an event can't possibly occur, its probability is what? Anyone know that one?
0.
Nailed it. When it's certain, what's its probability?
1.
Nailed it. I would also accept 0% or 100%. Right? You can answer these problems as percentages. You can answer them as decimals. It's up to you, which is what gets at number 3. Which one of these could represent a probability? And there's only 2, this one and this one, because those 2 numbers are between 0 and 1. All the others, oh, I'm wrong, this one. Those 3 numbers are between 0 and 1. The other 2 are not. This one's negative. You can't have a negative. This is over 1. As a decimal, this is 1.1. As a decimal, this is 0.06. Okay, I'm going to give you a second to do 4, 5, and 6 while I go make sure my little sweethearts are sleeping off their sickness. So just to make sure I've given you enough time, I'm going to give you 3 minutes to think about these, and we'll see how you did. So the timer for 3 minutes. Nice. You all giving me some answers. I like that. In case 26 seconds left. For those of you that aren't giving answers, if it's because you're stuck, here's what you got to think about. There's 6 numbers on this dice. You're going to roll it once. and we're getting a number greater than 2. So if I was to write this out symbolically, you don't have to do this, by the way. I might write it like this: x is greater than 2. So what we do is it's an awful sound, is we look at our sample space and we say, well, how many numbers are greater than 2 in it? Well, that's these 4. So there's a total of 6 numbers in the sample space. There's 4 numbers that meet the criteria for the event. So the answer is 4/6 or 2/3, or what is that? 0.6666 forever repeating. So you could do 0.6 repeating, or you could do or 0.67. That's what's approximately equal to, or 67%, or whatever. Next one, less than 4. There's 3 numbers. An even number, there's 1, 2, 3 of those, but you can't count them more than once. This is kind of an unfair question because we didn't really solve this, but less than 4 would be these 3, and then an even number would be 2 more added. So this one's really 5 out of 6. I'm not going to ask you this kind of question because it's really a unit 4.2 that we skipped. This or is a special deal, and these were not disjoint outcomes. Is this making sense, y'all? I think, let me see your answers. Don't worry about getting this one wrong. So let's see. Nice. Okay. So then for number 6, we got a box that's got 5 blue, 8 green, 3 yellow. Let's see. 3 plus 5 is 8. 8 plus 8 is 16. So our sample space, 16 total items in this box. And we're pulling out a green marble. So there's an 8 out of 16. Nice. I saw a lot of 1/2 as his answer. I would accept 8 out of 16. As a decimal, it's 0.5. As a percent, it's 50%. Those are all the options. Here again, our sample space is 13. Why am I saying boys? 13 children, 13 students. Probability we randomly select a girl from that list of 13 is 4 out of 13. Whatever that is as a decimal is what it is. Okay, how do we feel about this probability stuff? In terms of calculations, it's not going to get much more complicated than this. No, it won't be any more complicated than this. Your job is to figure out how many total things are there and how many things are in the event. Okay, so the next one is a set of what type of sampling method has been done. It says identify which of these types of sampling is used by indicating the correct number in the blank. Well, ignore that. Just circle the correct one. So let me give you 2 minutes for you to think about this, and then we'll talk through the answers. Set a timer for 2 minutes. Oh, sorry, everyone. Sorry. Okay. Let's talk through these. So you got a list of 15 facilities in your city, which you number from 1 to 15. Using random numbers, you choose 3 of the facilities and interview all the members in each facility. So notice the key thing that's happening here is you're grouping things, you're creating groups. You're selecting some of the groups and interviewing all of the people in the group. That's stratified. No, I'm sorry, that's cluster. So when you select some of the grouping and talk to all of the things in the group, or select all of the items in the group, you've done cluster. If you select all of the groups and do some of the items in the group, that's stratified. Does that make sense? You all feel good about that, or is that crazy? Nice. What have you got? 8 correct. Okay, you obtain a list of number, you randomly choose 400 members to interview. So this is just everyone, and you're randomly selecting some from all. You obtain a list of all the members of all and put them in alphabetical order. You select every 50th. That's the systematic. That's your clue, the thuff thing. And then you get a list of all the members, and you compile the names into a master list. You group them by age number. So you've done a grouped frequency distribution, and you select 100 from each age group. That's the example of stratified. Questions on that? Okay. So this, for some reason, this stems and leaves. This should be stem, should have been over here. There's a printing problem in this. And there really should be a key. Like without a key, this is meaningless. We can surmise from this that based on this question, that most likely how we are to read this is that this is a 1, 3 means 13 centimeters. So if we're saying how many grew to 25 centimeters, nail it, Jennifer. That's just this one thing, that one plant right there. How many plants grew to 36? Yep, these are 2 plants that grew to 36. How many plants were there total? That's all of them. So count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Boy, am I counting like my daughter? 13, 14, 15, 16, 17, 18, 19, 20. Nope, I did okay. And the longest one is this maximum, 59. Right, so this is just a check of, can you read a stem and leaf plot? And most likely, if I throw one of these on the final exam, that is what I would do. I'm not as interested in you constructing these stem and leaf plots. That's what we have software for. Can we construct a frequency distribution here? Sure. We're going to do these 4 categories. So this is a categorical frequency distribution. R, S, N, C, and then we just count how many are in each. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5. So the last one should be 9. Nope, 8. Wow, I miscounted. Nope, there it is. Oh, I miscounted. This one should be 6 because I missed that 1S. How are we doing? I'm going to skip this one. We're good so far. Excellent. How are you all in doing these things? Can you do these? I'm going to let you all do this one. In Desmos, I think is probably the best one. Although maybe I should ask, what methods do you all use to calculate these, or what technology are you all using? I have only shown you Desmos and Excel in class. So I'm curious if you all are good with that. Can you all do that? Try it. I'll set a timer for 3 minutes this time. I don't know if that was enough time, y'all, but I'm just gonna fill the answers. So there's the mean, there's the median, the mid-range is the maximum of A minus the minimum of A divided by 2. So if you don't know that formula, I would write it down. And then standard deviation, we should ask ourselves, is this a sample or a population? Sounds like a sample because it's a group of men, not all men that work. So we do stdev A, and there's all of our stuff. Right, so 46.675, 44.5, these are all on hours. Now the mode is the most repeated, and there is none. So there's no number that's repeated. Remember, it can be multiple numbers. You can have multiple modes. And then we're supposed to determine which number is it plus. Let me think. Yeah, that it would be plus. You're so right. It doesn't make any sense that 17 would be the mid-range. Thank you. Thank you. So 46.7. They're all pretty close together. Which is the best measure of central tendency and why? So what you look for, remember, is outliers. These appear to be listed in largest to smallest. And there doesn't appear to be, like, this number is kind of far away from this number, but really there aren't really any exceptionally far apart. The other thing you could look at is that the mean and the median are pretty close together in terms of hours. They're about 2 hours apart, 2.1 hours apart. So answers I would accept would be like mean, because there are no outliers, or median because 29.1 is an outlier. That's the only one that could be an outlier because these values are all pretty close together. So
is this different from the course pack that is on the classroom? Because I have different numbers that are on mine.
Did I open an old one?
I have, like, I don't have Robert on mine at all.
Interesting.
Oh, you know what? It's on the next page. It's not, it's all funky. Maybe it was missing that one from before. Never mind.
No worries. Christy, did you print yours yourself or did you get the one from the bookstore?
I got the one from the bookstore, but I couldn't find that page. So I just went on to the syllabus, the one that you have on there, and I opened it through my stuff. So it was just all set up funky. That was my bad. Sorry.
No, you're good. Because it could be, I should see what I posted on here, because it could also be like, if it's the Word document, sometimes when you download them, they get all wonky. And I mean, sometimes it's just my fault because I did a bad job. Yeah, like if you open this one, the Word might be weird, whereas the PDF might be a little better. But yes, that one number would make a significant difference. Cool. Cool. How's everyone feel about the measure of central tendency? We all feel about, what that was asking, right? And then how to answer. Either mean because there's no outliers, or median because there are outliers. Okay, good.
Mode is just the one that repeats the most, right?
Correct.
Okay.
So for this data set, there is no repeat, so there is no mode. Good. Skip this problem. We did not do this one. So this is an interesting question. 70th percentile rank on exam. If there are 300 students, how many students scored lower than Helga? Well, you would just do this. We didn't really talk about this either, so you don't really have to worry about this question, but I think it's a pretty straightforward question in terms of percents from unit 1. But there won't be a question exactly like this on the exam. Okay, this is a great question. This is a common question I like to ask on an exam, where you figure out which one has a larger standard deviation. Weights of all dogs at a golden retriever rescue shelter, weights of all dogs for sale in a pet store. Yikes, man, what do you think? Does anyone have any? So the pet store is going to be higher. Why? To me, this is a tough one. Like it could go either way. Basically, I would accept either answer. As long as you're reasoning. So I don't see, Jennifer, yours was just to me. So Jennifer in the chat said the pet store because you may have large dogs and tiny ones, which makes sense to me. And then Mike, I like what you said too. I say shelter because you'd have grown dogs too. Here's what's in my head. I would think a pet store is going to mostly have puppies, puppies, and that a rescue shelter is going to have dogs. So the fact that it's a golden retriever rescue shelter, first off, does that even exist? Like, oh, I'm sorry, we only rescue golden retrievers. Your dog doesn't, this dog can't come here. The point is, I think all golden retrievers are going to be roughly the same size. So that might be one good argument, is that the pet store is going to have a variety of sizes, big and large. Whereas the rescue shelter, but then the rescue shelter could have puppies and adults, and it's just, it could go either way, or it could be like malnourished golden retrievers because there's owners that don't take care of their animals, or like extremely overweight golden retrievers. Like rescued animals might have unhealthy weights. So you just, when you pick your answer for this one, you just need to make a good argument about why one has a wide variety of ranges, or a wide variety of weights, or a larger variety of weights than the other. Like, that's the key part. That's what standard deviation is a measurement of, that there's light dogs and heavy dogs and a big mix of them, and one of them is more mixed up than the other. Does that make sense to everyone? Has anyone got any questions on that one? So I don't disagree with anything you all said in the chat. I really like question 19. We actually talked about it in the textbook. It's the same question. We got a class that has a mean of 72% with a standard deviation of 3.2%. And then we got another class that has a mean of 72. What is the same mean, 72%, and a standard deviation of 18.2%? So what are we going to say about these classes? Everyone scored about the same here, right? So everyone's roughly passing. And this one has some wild variation. If these were normally distributed, we've got some students scoring in the hundreds or over 100, and some scoring, like, we're up to 3 standard deviations away as expected. Some scoring in the low 30s or below. Whereas with this one, 3 standard deviations above the mean is just at 9%, roughly 9% more. Yeah, 9.6, which gets us to an 81. So the highest possible exam potentially, if they're normally distributed, is in like an 81, whereas this one is over 100%, which would suggest that these data values are not normally distributed. Clearly, these are more spread out. Some students scored well, some students scored poorly. Everyone's about the same. Okay. This is a super important question. Being able to do this is what you're doing on the project with the milk data. So you're assuming a data set is normally distributed. That means all the empirical rule stuff happens, and we've got a mean of 13 and a standard deviation of 3.5. I'm using population symbols because this has no context. So let's just assume it's a population. So where does the 13 go? Yeah, exact middle. Excellent, you all. Nice, you're remembering. And then how do we get the 3 upper values? Good. Add the standard deviation to the mean. So we add it once and we get 1 standard deviation above the mean. Add it again, we get the next standard deviation. Add it again, we get the next. You know what's coming next. How do we get the below ones? You're right, Alyssa, we could do like, this is 13 plus 3.5. This is 13 plus 2 times 3.5 for this one. And this last one is 13 plus 3 times 3.5. Like that's the other way. That's how the textbook shows it in the thing. Nice. And so then below we subtract. So what? 9.5, 6, 2.5. Okay, so there's our our x-axis values. Is it 7? Which one did I see? Oh, wait. No, wait, what? Oh, your answer to this one. Okay, I got you, Jennifer. No, you're probably right. So then the question says approximately how many data values fall within the range 9.5 to 16.5? Okay, well, you need to have the empirical rule put into place here too. So we need to know the percentages in between each of these tick marks. That's a memory thing. That's a thing that should go on your reference sheet. In other words, it's 0.15% above 3 standard deviations. It's 2.35% between 1 and 2. It's 13.5%, sorry, 2 and 3 here, between 1 and 2, and it's 34% between here and here. And then it's symmetrical across the bottom. Nice. So just repeat, 34%, 13.5%, 2.35%, and 0.15%. Then if we're going to figure out how many are in between, we're looking at, this is the area between 9.5 and 16.5. So we first have to say what percent of the data values fall within there, and we just add together the two percentages. That's 68%. So we need to calculate, back from unit 1, what's 68% of the 50 data values. Whatever that is the answer. Turns out there's 34 values. This is the exact same question, so I'm going to skip it. I'll let you all do it. Although we'll do it. There's another one on the second review, the review B, which is the one you're going to turn in. So we'll skip to that one. Any questions on this? I don't want to, I feel like I'm flying. Maybe I'm going too fast. How's everyone doing? Good. There'll be one like this on the final exam too, where I just give you a normal curve and you need to fill it out, and then you answer some questions about it, kind of like the 4-7 worksheet. Okay, then let's look at number 22. Here we're to assume that males have a mean height of 69.1 inches. In case we care, we could go back to unit 2 and figure out what is that in feet by converting it from inches into feet. Hey, that's 5.75. So let's see how many 5'9". Hey, that's my height. I'm 5'9". With a standard deviation of 2.9 inches, and females have this mean height with this. Based on z-scores, who's taller, a 5'4" male or a 4'10" female? Okay, so first we need to recall what the z-score formula is. We wrote that in our reference sheet at the beginning of class, or not too long ago. So it's the data value minus the mean divided by the standard deviation. We have to calculate 2 z-scores, one for the male and one for the female. And then we have an issue here, right? This is 5'4" for the male and 4'10" for the female. So we need to convert those into inches only. So hopefully you remember there's 12 inches in a foot. And so if we have 5 of them, 5 times 12 is 60. So for the male, that male is 64 inches tall. And for the female, it would be 48 plus 10, they're 58 inches tall. Now, if we were just standing them back to back, the male is taller, right? Absolutely taller, just an amount of inches that they have. But what we're wanting to know is if we were to standardize them, because on average males are taller than females, we want to see who's the taller person relative to their gender. That's really what this question is about. So we'll calculate the z-score for the male. That is, take their height, subtract the mean height of a male, divide it by the standard deviation of a male. Take the height of the female, subtract the mean height of the female, divide by standard deviation. This will get us our z-scores. Whichever z-score is larger is the taller person relative to their gender's height. So if you like fractions, I'm sure you don't, but it's helpful to, I think, treat this as a fraction. So I just hit the division sign in Desmos to get that fraction bar set up so we don't mess this up. This is a calculation that's easy to get wrong if you're just using those old school calculators, because if you don't use parentheses around the numerator, it'll divide these two numbers and you'll get a wildly wrong number. All right, so the male is negative 1.759 is their z-score. Talk to me. Maybe that was in the noises. Okay. Maybe I'm just hearing things. And then let's get the female z-score. So the female is negative 2.111. Okay, so the male is relatively taller based on the z-score. The male is only 1.759 standard deviations below the mean, whereas the female is 2.111 standard deviations below the mean, which of course is how you would interpret that z-score. Let me pause there and let you contemplate. Does anyone have any questions? I'm going to skip 23 because it's the same as 22. And I'm going to go ahead and skip 24 as well because it's the same as 20 and 21. So I'll leave those for your practice. If you look at my old YouTube channel for this class, I worked through these problems on that. So your job now is to do the Unit 4 Review B. We have a solid hour of class left. I think we can easily get through that, but I want to first talk about the final exam real quick. Just kind of give you a rundown of what to expect and where you will find it, and then I'll give you time to work on this, and we can go over your answers if you want. If you're like, if that's not something you want to do, you do what you want, of course. So first, I'm going to open up. I'm going to change this module where it says midterm. I'm going to add to it midterm and final. And so the final exam is here. I will make it visible sometime today. And you will have from today until Thursday at midnight to complete this. And it'll just be a one-time take, and you need to have your, you need to make sure your lockdown browser is working. I will maybe dump in the practice quiz. I'll move that up there. I'll put this practice quiz back in there in case you want to test whether or not things are working for you, and let me know. Please don't wait till the last minute like a bunch of people did for the midterm and then weren't able to take the midterm because time ran out. There is no extension this time around because it's the end of the semester and I have to turn grades in. So this is an absolute deadline that you must meet. And if you don't, you just get a 0 and we all move on. Unfortunately, that's my hands are tied on that. So just make sure things are working. And if there are problems, let me know so we can troubleshoot. That's what it will be. As for the exam itself, it will be very similar to what you encountered on the midterm, just everything. So let's see. We're gonna say that I'm gonna give you like a 3-hour time limit. And if you think that's not gonna be enough, let me know. Maybe I'll do 4 hours just to make sure. The main point is I don't actually care about a time limit. I just want it to be once you start it, you finish it. It's Respondus, as we just said, which means you are video recorded and lockdown browser. So video recording with lockdown browser. That means you will only have access to Desmos, which is what we have been using throughout class. That's how I've taught you to do the problem. So you should be okay. You shouldn't need access to any other technology really, but you're also allowed, you can also use a calculator. It's just in terms of web services, that's the only website you're going to be allowed to use. You're allowed your reference sheets. I don't know how many we've said. So I'm just going to say 6 pages of reference sheets, double-sided. I think this is probably common knowledge, but most students don't abide by it. More is less. So you should think carefully about what you put on there. Just cramming tons of information on there isn't super useful. Although, in my experience with reference sheets and qualitative responses from students, they find that the stuff they write on their reference sheet is useless, and the stuff they need that's not on there is what they needed. Which is really, I'm tricking you all into studying, right? By organizing the information and writing it down, you are kind of internalizing it. And then you got the security blanket of, oh, I don't have to memorize it. I can go, it's right here, I can look at it. And then it turns out you might actually have it memorized. And the fact that you're relaxed that you have it means you don't really need it. So taking time to write a good reference sheet is super useful, even if you don't end up using anything on it or needing to look at it at all. The fact that you created it usually means you can do better on the exam. That's not always true. I've had students that just copy someone else's reference sheet. It's garbage. It's not particularly helpful because you don't know what they were thinking when they wrote it down. It's not written in your language. And then, like, if you haven't been watching the videos or coming to class and looking at the things I'm telling you to write down, that's also might not be as useful. I'm the one that wrote the exam, so I know what the questions are going to be on the exam. And to that, the questions that are on the exam are the same questions from the worksheets. I wrote the worksheets for better or for worse, all the mistakes on them, and there were a lot this semester, are what's going to be on the exam. So they will look like the worksheets. Now, that's kind of not true in terms of the fact that it's a digital version. So how things are laid out on the page of a worksheet, it looks different than how they're laid out on the screen in Canvas, unfortunately. So when I take, say, one of these questions and translate it onto the screen, it might not look exactly the same, even though it's the same type of question. It's a little unfortunate, but just know that the wording and the types of questions are based off of what you've been seeing in the worksheets. So look back at your unit reviews for practice, and then you can also look back at all the other worksheets. In terms of content, it will be sequential and it's cumulative. So it's units 1 through 3. Units 1 through 4. So everything we've covered for the course. I would say it's probably, don't quote me on this, this isn't exact, so this is approximately 25% units 1 and 2, and approximately 75% units 3 and 4, right? I've already tested you over 1 and 2, so I don't really need to test a ton of it. But expect some percent problem like relative change or percent change, one of those types of questions. Expect questions about a linear or exponential model and interpreting parameters like you did on project 2. And then expect a bunch of like monthly payments calculations and total cost calculations and tax questions and normal distribution questions, all stuff from units 3 and 4. So you really, really, really need the most important reference sheet is the unit 3 reference sheet, because there's a billion formulas in there, right? Calculate compound interest, compounded continuously, the unearned interest formula, all that mess. So go back and watch that unit 3 review video if you haven't yet and haven't created the reference sheet. And I think thanks to Mike, I emailed out the thing I wrote up, the reference sheet. Again, make that thing your own though. Don't just copy what I wrote down. Make sure whatever you write down is something that you understand. Length. I'm going to stop sharing it because I do have this written, and I can't minimize. Oh, come on, because I'm recording. I'll just open it up and tell you how many questions. There are, well, let's see. There are 21 questions on this exam, and they do have parts A, B's, and C's. In terms of like lengths of like comparative length to the worksheet, let me open up the Word document that I had written for it. Hey, I found it. In terms of number of pages, it is a 13-page document in terms of a Word document. So 13 pages long. Don't be crazy intimidated by that. That sounds big, but there's a couple pages where there's like half of the page is a graph because it's just a really big graph. So it is a little bit longer than the midterm because it is like a bigger exam, but it's not, I wouldn't say it's crazy long. And in some ways it might, I don't know, it might be, no, it is bigger. So 21 questions, it was 13-page Word document. Is there anything else that you think you would like to know about the final exam? Any other pertinent information that would be helpful in your prep for it? Okay. Oh. All right. So what I would like to do is give you time to work on each of these questions, and then we go over the answers. So how much time do we think we need on the first page? Let's do 3 minutes for questions 1 and 2 and see how far you get. So timer for 3 minutes. So I've seen some answers. Those are the three that could represent probability for number one. Number two, this is a strange one. Might write it this way. Totally fine if you use commas otherwise. Key point here is that the sample space is 6. There's 6 ways to order 3 different numbers. Yeah. I think, Christy, if you go to, if you downloaded the Word document, well, let me see, maybe it's, I wonder if the PDF was the one that's messed up. One of the two of these is, see, this is like the last couple pages. Pages this, because I could just go straight to it. This is page 97. Looks good here. So I'm guessing it's the Word document. Although it could be that the viewer here. It could be that the thing, how it's being viewed here is doing it. And that if you download it, it'll mess it up. Yeah, that's quite unfortunate. I'm sorry. Okay, so 6 ways. So here's the key thing you have to get for B. You have to understand that this is the number of ways you can win. So there's 6 ways you can win. There's 1,000 ways you can pick these 3 different numbers where the order of the number doesn't particularly matter. So the probability you win is 6 out of 1,000, which as a decimal is 0.006. And as a percent, that's 0.6. This is why the pick 3 lottery is profitable for any state or whoever runs a pick 3 lottery. It's going to be profitable because everyone's picking numbers and this is your chance of winning. It's approximately 1% chance of winning, right? So there you have it. Yeah, I'm gonna let you all do this one. I think we should be okay. Maybe should we look through? Are there any of these that like you think? I guess we could keep going. How about I give you all 3 minutes to answer these, and then when you're done, let me know. So I'm hesitant to just give you all the answers because giving you the answers removes the power of the review. Right? The review part is you figuring out if you actually know them or not. So let me give you 3 minutes, and then if you have the answers, you tell me sooner. So the time for 3 minutes. Yeah, probably one of them's cluster. Definitely agree with this one. This is a grouping. We're selecting some from the 2 groups we've created, and we've only created 2 groups. That would make it stratified. Here's a grouping, and we're selecting all from that grouping, which would make this one cluster, and then the Thuth one systematic. Turn off the timer. Okay, totally didn't give the rest of you enough time to respond, but the answers were already in the chat, so I thought we might as well confirm it. You can see that you need a decent understanding of each of these. You need the definitions of each of these in your reference sheet in order, like if you don't know what these are, how could you answer these questions? Okay, let's do 3 minutes on this one. See how you do. Set time for 3 minutes. Again, if you get done early, let me know. Maybe put your answers in private chat so everyone else doesn't get so you don't create bias in other people's responses. Ooh, you like that? Okay, well, that was like 3 minutes. So let's chat about it. I've seen at least a couple answers. So how most often how these things work is in the prompt, you're told the sample specifically, directly. And then you have to identify or infer the population from the sample. Now be careful here. There is many students want to tell me the sampling method, and we don't necessarily know the sampling method. That's often not listed like in the summary of a study or the summary of a survey. If you want to know those things, you usually have to dig into the deeper write-up of the survey. I got this particular survey from, I don't even know how to pronounce this, Quinnipiac University, maybe. And I didn't go into the deeper stuff to figure out everything. I just grabbed the results. So the sample is right here. Remember, the sample is always some. So when I say be specific, it's the 1,355 self-identified, meaning the when this company called them, they didn't look up the list of registered voters. They didn't go to the voting people, I don't know, the state's voting records and pull people from there. They just called people and said, are you a registered voter? And the person said yes or no. So there's some trust there. Like someone could lie. I don't know why they would, but they might. So 13, and I might put the US here because these are US voters nationwide. Like this doesn't clearly state it's the US, but as soon as you see that it's Joe Biden, Joe Biden, then we know this is the US because these are candidates in America, not some other country. Okay, then if you recall what we talked about in the four section, to state the population, you just replace the number with the word all. And that's usually if the sample was set up nicely, that's usually the correct answer. Sometimes the sample that's been collected isn't very good. Like whoever did the study did a bad job creating their sample. And really, if you look at this, I would think it is a bad sample because we're looking at the Democratic presidential nomination. Well, the only people that can vote in the Democratic presidential nomination are registered Democrats, as far as I recall. Although in Michigan, in the Michigan primary, you can vote in either, no matter your party affiliation, you can vote in either primary, but you can only vote in one. But most states, you have to be a registered Democrat to vote for that primary nomination. So it might be better to state here, or more accurate to say, all US Democrat voters, right? Because this is their nomination. And then most everyone, Joe Biden, I don't know, at least I was consistent between these two, right? The last one is how many people voted for him in the nomination, 0.13 times what, the 1355. And let's see, someone put this in chat. 325 people out of that sample said, I want Joe Biden to be nominated. How do y'all feel about that? Does that seem okay? Is anyone lost? I'm just going to tell you the answer is this. Remember, categorical are oh, did I get the wrong number? Yep, you're right. Thank you, Jennifer. This should be 0.24. I was not reading carefully. So the 24% goes with Joe Biden, and the 13% goes with Bernie Sanders. Feel the burn. Okay, categorical variables are going to be eye color and hair color, just those two things that are names or categories that don't have numerical measurements for them. All right, let me let you do number 9. If you can't get started, send me a message so I can give you some hints if you have no idea how to do it. Set a timer for 3 minutes. Okay, so this one, we're just making sure you can calculate a z-score. And this is a common mistake students used to make when they used like a calculator like this. And I can show you how that happens. So basically, to say which student is correct, just take the data value. Let's see, we'll note that the mean is 61, the standard deviation. Let me change this. I guess it's not too bad. I like green. Let's change it to dark green. Standard deviation is 22, and both students got a 68. So we're doing 68 minus 61 divided by 22. Remember, it's data value minus mean, not date. Data value minus mean divided by the standard deviation. So this is how it's calculated. Now we're trying to trick students because students made them. We're not trying to, maybe we were. Like if you just type this in, I did 68 minus 61 divided by 22, you get the 65.23. That's because the calculator does order of operations. It divides first, then subtracts. You can see it, how it's written here, right? If you use Desmos, and do the fraction thing, like there's no problem. Or if you just keep track of making sure you type it correctly into these old calculators. So this is the correct answer, 0.31818181818 forever and ever and ever. That means the correct answer is student A. And how do you know? Because they calculated it correctly. I don't know, because you did this, right? And how do you know B is wrong? Because they got the wrong answer. One of the arguments, I like, Jennifer, what you said, this number is insanely large. It's saying that 68% is 65 standard deviations above the mean. That means we would take 22, multiply it by 65, and that should be where 68 is. That's wildly insane. Like there's no way that's possible. 68 is quite close to 61. And if you look at the standard deviation, if you think about your graph here, if 61's here, the first standard deviation above the mean, one standard deviation above the mean is, wait for it, come on, eraser. Wait for it, 61 is 83. So 68 is like right here. So that tells us that the number has to be less than 1, which is, Jennifer, what you said. It's got to be a number between 0 and 1. Excellent. Great work, y'all. Does anyone have any questions on that? Is everyone feeling good? This is an awful question. Using 6 classes, calculate the class width. Let's skip this one. This one's just tedious. Nice. Yeah. Nice, Mike. What you want to do with your classes here, right? You want to set up your lower limit and your upper limit. You want to calculate your class width here, and then you're going to calculate your frequency and do your thing. Let's skip down to, oh, you know what? You're going to skip this entire question because we did not do this. We skipped this as a class. So skip this. Shoop. We kind of did it. We did it with your grade stuff, but let's just skip it entirely. And let's jump to here. So let's jump to question 12. And this is the one where you're doing, these are all the calculations like you're doing on project 4. Can you find the mean, median, mode, min-range, range, standard deviation, and coefficient of variation? This is a good data set for a stem and leaf plot. If you look at the numbers, 0, 1, 2, 3, 6. So I'll get the setup for you. This is what your stem should look like. You fill in your leaves, and I'll give you a key, and you fill in the rest. So let me give you 5 minutes. You got some typing to do in Desmos of all these data values, and you got some whatever. Let me give you 5 minutes on this one. Set a timer for 5 minutes. Okay, that was 5 minutes. Y'all need more time or did y'all get it? Okay, let me give you like 2 more minutes. Okay, let's see, I'll slap in this stem and leaf plot. That's what it should look like. Definitely not a normally distributed data set, but we didn't really talk about that, so don't worry about that. And then I've got my answers typed in Desmos here. Nice. So for the mean, yep, I got 14.67. For the median, I got 11. For the mode, I got 1. For the mid-range, I got 33.5. For the range, 65. You can see I typed them here. Is this the same numbers you all are getting? I should check. Okay, yes. If you did 1 decimal place, that's fine too. No worries. Standard deviation, 14.30 if I do a couple, and then coefficient of variation 0.97. You could also say 97%. Awesome. Does everyone feel good about that? Anyone, does anyone have any questions? Anyone lost in that mess? Okay. Please feel
I
comfortable.
messed up. Sorry.
Go
I
ahead.
messed up the mid-range. I got 4.55 for some reason.
That's probably because you copied what I did before, where I did minus divided by 2 instead of plus. That's like my fault. Maybe not. Or maybe I screwed it up. Wait, let's see. Did I screw it up? No, I did okay, I guess. I don't know. Like this is how I calculated, Mike. Did you?
Let me check really quick. Sorry, I'm doing all this on my phone.
You're good. I'm sorry. Yeah, that's rough. Oh, I should have also said, y'all, you could have done 97% here for coefficient of variation. Good Lord, what's the best measure of central average? That's the dumbest. Who wrote this? It was me. I know. I'm upset at myself. That should be there. This should either say, what's the best measure? Come on. What's the best measure of average? Or it should say, what is the best measure of central tendency? Those are the only two ways it should be. Did you all have a chance to think about that? Nice, Jennifer. Yep. So I will remind you of your thoughts here. These are all measures of central tendency or average, those four. These three are measures of spread or variation. So we're picking between those two. Yeah, this answer is median because 66 is an outlier. Like, it's a crazy outlier, right? It's like, if you look at what this data is, this is an old online math thing. Today's equivalent is Alex. So this is the number of hours students were working on their online homework. So the equivalent, I could have done this for our class. How many hours did you all spend logged in Alex working on your Pi? And this is real data. I had a whole bunch of students that spent like under 10 hours. I mean, that's the most common amount. They did not do well on their online homework, right? Because that is not enough time to complete it, especially like here-ish, right? But this student, 66 hours. That's a clear outlier. The next closest is 33. So definitely an outlier, and that's what you look for. It's either the mean if there's no outliers, or the median if there is outliers. No worries, Jennifer. The last question is this one, so I think you'll be fine. Okay, and then we're supposed to describe the variation using the standard deviation and coefficient of variation. Based on these two values, the data set is very spread out. And it's really because of this 66 and these ones. That's, there's 65 hours between the student that spent the most time working and the students that spent the least amount of time working. So that's really what you're talking about. 97% of the mean is the standard deviation. There's a 14-hour spread in the amount of time usage. You could look at this graph, and there's like this big gap between this set of students and this one student. And really, if you think about measurements, even here, this is a big gap of 20 to 30 hours, double-digit hours versus single-digit hours. So it's just a very spread out data set. What do y'all say for number 13? Which data set has the larger standard deviation? The height of an NBA basketball player, or the heights of NBA basketball players, or the heights of high school boys? Yeah, yeah. So Mike's saying it's the high school boys. Um, so definitely. I don't know how much y'all know about NBA basketball players. The mean height of that population is like 6 foot. Um, and essentially, you have to be that tall to get in the NBA, not because there is some sort of requirement. That's just what happens, right? And if you're talking about high school boys, think about like puberty and a freshman versus a senior, and like all that. So these boys are going to be all over the place in their heights, whether they've hit their growth spurt yet or not. Boy, I'm so glad I'm not in high school anymore. I remember those days. Whew, yeah. Okay. Last question. We're about out of time. So here it is. I give you a mean. I give you a standard deviation. I say do this and do some calculations. Same question we've already done. I don't know. Let me just give you 5 minutes, and then there won't really be time for me to write up all the answers. We can talk about. You can ask me which ones you want to talk about. Set a timer for 5 minutes. Nice, Mike. Nailing it. Okay, we're mostly out of time. Those of you who have submitted answers nailed it. Is there any one of these that you all want to, like you feel like you have no idea on? That's a great question, Mike. It probably isn't multiple submissions. I will fix that right now. So if there's no other questions, y'all take off. Have a great evening, afternoon. I'm finishing. I got all of project 2 graded yesterday. I started project 3. I didn't get very far. I'll get that. I'm gonna have that graded today, and project 4, I guess, isn't due till tomorrow, so I guess I don't have to have that graded today. I will get those in. What am I doing? Oh, I know what I'm doing. So your grades will be updated, unlike all semester long. What I'm not going back to the stuff that was turned in late quite yet, but I will get to those after I've graded everything that was turned in on time. And that will be, there we go, unlimited. That will be that. Laquita, remind me of what you're referring to, because I'm sure I've forgotten already. You too, Mike. Okay, so yeah, if you sent in stuff, I will look at them for sure. I'm gonna have the grades between tonight and tomorrow. I'm gonna have them completely updated so people can look at them and say, oops, you made a mistake, fix it. And that you'll have time to make sure it's fixed. I am gonna lock submissions at some point. So I had intended to lock them tomorrow or Sunday for a bunch of stuff, but I'm gonna leave them open for a bit. And you'll have a chance to look up, like if I miss that, God forbid, I'm not going to finish grades till the 20th. So there'll be time for you to scream at me to make sure I get them. So according to the syllabus, and really the college in general, a 2.0 is a passing grade. And so the way the syllabus is set up is that a 70% is the bottom 2.0, but I round to the nearest percent. So if you have a 69.5% by the end of after all the grading is said and done, you would pass the class, because that would round to a 70. So that's the passing grade.